All right, question number 8. We want to determine if the function is continuous at a, and we want to use our checklist. So we have f of x is equal to 8x minus 1. We're dividing by x squared minus 9x plus 8, and we're saying a equals 1. So first thing I would try to do is see if this factors so I can see the linear terms. And the top will not break down to anything. On the bottom, I think it does factor. 1 times 8 is 8. Factors of 8 are 1 and 8 and 2 and 4. We want to add to get 9. 1 and 8 add to 9. So 1 and 8. And since we want to get a negative 9, we would have a minus and a minus, both negative. Okay, so if I plug in a 1, we get a 0 on the bottom. 0 times 0, we get 0. So this would not be continuous at 1. It's not defined. So we will say f is not continuous. It's not defined. There we go. Number 9, we want to determine intervals on which the function is continuous. So we're going to find continuous functions. Again, similar just by finding the domain. So if I go to number 9, f of x, we have x squared minus 4x plus 3. And then we have an x squared minus 1, so we can factor that with difference of squares. So just focusing on the bottom, x plus 1, x minus 1. So we get 2 values, and like even if the top factored out, they didn't want to know if it's a whole or an asymptote or anything. They just want to know where is the function continuous. And so we would have to remove 2 points, -1 and +1, and that will give us the interval negative infinity up to -1, and then we will go on the other side, -1 to +1, and then we would go +1 to infinity. So like if you had a number line, this is negative infinity and positive infinity. We would have a hole at -1, that would be a break, and at +1. So that splits your number line in 3 pieces: negative infinity to -1, -1 to 1, and 1 to infinity. So that's where we're getting these 3 continuous pieces from. We'll use interval notation, negative infinity to -1, comma to separate, -1 to +1, and 1 to positive infinity.